According to the National Electrical Code, single-phase panels can be supplied from a 120/208 volt, three-phase electrical distribution system provided certain conditions are met. NEC Article 210.6 states that single-phase, two-wire branch circuits shall be supplied by a single hot conductor and a neutral conductor. In this case, the 208-volt phase neutral voltage would be used for the hot conductor, and the neutral conductor would be bonded to ground. NEC Article 210.10 states that branch circuits supplying loads rated at 120 volts nominal between conductors shall be supplied by a neutral conductor. Therefore, the 120-volt phase neutral voltage would be available in the panel for loads rated at 120 volts. NEC Article 210.10b provides an exception that allows single-phase panels to be supplied from a three-phase system with a neutral conductor, provided that firstly, the panel feeds only three-phase loads such as motors, and secondly, the voltage to ground does not exceed 150 volts. Based on the NEC requirements, it is permissible to supply 120/208 volt single-phase panels from a 120/208 volt three-phase electrical distribution system, as long as the conditions stated in the NEC are met. Let's delve deeper into the specific NEC articles to clarify the requirements. NEC Article 210.6 concerning branch circuit voltage limitations ensures safety and proper utilization of electrical systems. The phrase single-phase, two-wire branch circuit shall be supplied by a single hot conductor and a neutral conductor is crucial. This configuration allows for the utilization of the 208-volt phase to neutral voltage, providing a higher voltage option while maintaining the availability of a neutral for 120-volt loads within the panel. The requirement for a neutral conductor in this scenario is paramount for ensuring balanced loading and minimizing the risk of voltage imbalances within the electrical system. The neutral conductor, being bonded to ground, provides a low impedance path for fault currents, facilitating the operation of overcurrent protective devices such as circuit breakers or fuses. This grounding mechanism is essential for preventing electrical shock hazards and ensuring the safety of personnel interacting with the electrical system. NEC Article 210.10 further clarifies the requirements for branch circuits supplying 120-volt loads, by stating that branch circuits supplying loads rated at 120 volts nominal between conductors shall be supplied by a neutral conductor. The code emphasizes the importance of providing a stable and reliable 120-volt supply for commonly used appliances and equipment. The availability of both 120-volt and 208-volt circuits within the same panel offers versatility in accommodating a wide range of electrical loads. This configuration is particularly useful in multi-tenant dwellings or commercial buildings where diverse electrical needs are anticipated. The exception outlined in NEC Article 210.10b addresses specific scenarios where a neutral conductor is not required for single-phase panels supplied from a three-phase system. This exception applies only when the panel feeds exclusively three-phase loads, such as motors or other industrial equipment. In such cases, the absence of a neutral conductor simplifies the wiring configuration and reduces the potential for circulating currents. However, it is crucial to ensure that the voltage to ground does not exceed 150 volts, as this limitation is essential for maintaining safety and preventing equipment damage. The NEC allowance for supplying 120/208 volt single-phase panels from a 120/208 volt three-phase electrical distribution system provides flexibility in designing and installing electrical systems for various applications. By adhering to the specific conditions outlined in the NEC, electrical contractors and engineers can ensure the safety, reliability, and compliance of their installations. Furthermore, a thorough understanding of the NEC requirements is essential for avoiding costly mistakes and ensuring the long-term performance of electrical systems. Remember to consult the latest edition of the NEC and seek guidance from qualified electrical professionals when designing or installing electrical systems. This ensures adherence to current codes and best practices. The NEC serves as a comprehensive guide for safe and effective electrical installations. It's important to stay updated with the latest revisions to ensure compliance and safety. The information presented here is for educational purposes and should not substitute professional advice. Always consult with a licensed electrician or electrical engineer for specific applications. Electrical work can be dangerous, and safety should be the top priority. Understanding the NEC requirements is crucial for anyone working with electrical systems. This knowledge helps prevent accidents and ensures that installations meet safety standards. The NEC is a living document, constantly evolving to address new technologies and safety concerns. Regular review and updates are essential for staying informed. The principles discussed here apply to a wide range of electrical installations, from residential to commercial and industrial settings. Understanding the fundamentals is key to successful electrical work. Single-phase panels are commonly used in various applications, making this knowledge relevant to many electrical professionals. The NEC provides detailed guidelines for selecting and installing electrical equipment. Proper equipment selection is critical for safety and performance. The NEC also addresses grounding and bonding requirements, which are essential for preventing electrical shock hazards. Proper grounding and bonding create a safe path for fault currents. Overcurrent protection, such as circuit breakers and fuses, is another critical aspect of electrical safety. These devices protect circuits from overloads and short circuits. The NEC specifies the requirements for overcurrent protection devices, ensuring that they are properly sized and installed. Wiring methods are also covered in the NEC, providing guidelines for safe and effective wiring practices. Proper wiring methods minimize the risk of electrical fires and other hazards. The NEC also addresses conductor sizing, ensuring that conductors are adequately sized for the intended load. Undersized conductors can overheat and cause fires. Load calculations are an important part of electrical design, ensuring that the electrical system can handle the anticipated load. Accurate load calculations prevent overloads and ensure reliable power. The NEC provides methods for calculating loads in various types of buildings. Voltage drop is another factor to consider in electrical design, as excessive voltage drop can affect equipment performance. The NEC provides guidelines for minimizing voltage drop. The NEC also addresses emergency power systems, which provide backup power in the event of a power outage. Emergency power systems are critical for hospitals, data centers, and other essential facilities. The NEC specifies the requirements for emergency power systems, ensuring that they are reliable and properly maintained. The NEC also addresses renewable energy systems such as solar and wind power. Renewable energy systems are becoming increasingly popular, and the NEC provides guidelines for safe and effective installations. The NEC is a valuable resource for anyone involved in the electrical industry. It provides the knowledge and guidance needed to design, install, and maintain safe and reliable electrical systems. Remember to always consult the latest edition of the NEC and seek guidance from qualified electrical professionals when working with electrical systems. Safety should always be the top priority. Electrical work requires specialized knowledge and skills. Improperly installed electrical systems can pose serious risks. Always hire a qualified electrician for electrical work. A qualified electrician has the training and experience needed to ensure that electrical work is done safely and correctly. Electrical inspections are also important for ensuring that electrical systems meet safety standards. Electrical inspectors review electrical installations to verify compliance with the NEC. Regular electrical inspections can help identify potential hazards and prevent accidents. Staying informed about the NEC and best practices in the electrical industry is crucial for all electrical professionals. Continuous learning and professional development are essential for staying up to date. The electrical industry is constantly evolving, and new technologies and techniques are emerging all the time. Staying informed about these changes is important for providing the best possible service to clients. The NEC is a complex document, but it is essential for ensuring electrical safety. By understanding the NEC requirements and following best practices, electrical professionals can help create a safer world. The goal is to design, install, and maintain electrical systems that are safe, reliable, and efficient. The NEC provides the foundation for achieving this goal. This overview provides a starting point for understanding the NEC requirements for single-phase panels supplied from a three-phase system. Further research and consultation with experts are recommended for specific applications. Always prioritize safety and compliance when working with electrical systems. The information provided here is for educational purposes only and should not be considered a substitute for professional advice. Consult with a qualified electrician or electrical engineer for specific applications. In summary, when considering the use of 120/208 volt single-phase panels in a system supplied by a 120/208 volt three-phase source, ensure compliance with NEC Articles 210.6 and 210.10 A and B. These sections cover the requirements for neutral conductors, voltage limitations, and exceptions for specific load types. This careful consideration will result in a safe, functional, and code-compliant electrical system. Be sure to double-check all of the applicable requirements in your jurisdiction and always consult a qualified electrician before undertaking any electrical work. The information provided is for educational purposes only and should not be considered a substitute for professional advice. The NEC is the definitive standard for electrical safety in the United States, and familiarity with its contents is crucial for anyone involved in the electrical industry. Regular training and education are essential for staying up to date with the latest changes and best practices. Safety should always be the top priority when working with electricity, and a thorough understanding of the NEC is a key component of a safe working environment. Furthermore, it is recommended to consult with local authorities and inspectors to ensure compliance with all applicable codes and regulations. The NEC provides a general framework for electrical safety, but local jurisdictions may have additional requirements. By following these guidelines and staying informed about the latest developments in the electrical industry, you can help create a safer and more reliable electrical system. The information provided here is intended for educational purposes and should not be considered a substitute for professional engineering advice. Always consult with a qualified electrical engineer for specific project requirements. Electrical design and installation should always be performed by qualified professionals who are familiar with the NEC and local codes. Safety should always be the top priority when working with electricity, and a thorough understanding of the relevant codes and standards is essential for ensuring a safe and reliable installation. It's important to remember that this information is not exhaustive, and there may be other factors to consider depending on the specific application. Always consult with a qualified professional before making any decisions about electrical design or installation. They could help you ensure that your system is safe, reliable, and compliant with all applicable codes and regulations. Ignoring these considerations can lead to serious consequences, including electrical fires, equipment damage, and personal injury. Therefore, it is crucial to take the time to properly design and install your electrical system, and to seek professional assistance when needed. The NEC is a complex and constantly evolving document, so it is important to stay up to date with the latest changes. Regular training and education are essential for ensuring that you are familiar with the latest codes and standards. By following these guidelines, you can help create a safer and more reliable electrical system for your home or business. The information provided here is for educational purposes only and should not be considered a substitute for professional advice. The NEC is a living document that is updated regularly to reflect changes in technology and best practices. Staying current with the latest edition of the NEC is essential for ensuring that electrical installations are safe and compliant. The NEC is not a design manual, but it provides the minimum requirements for electrical safety. Electrical designers and installers should strive to exceed these minimum requirements whenever possible. A well-designed and properly installed electrical system can provide years of reliable service. Conversely, a poorly designed or installed system can be a source of problems and potential hazards. Therefore, it is important to invest in quality materials and workmanship. The NEC is a valuable resource for anyone involved in the electrical industry. It provides the knowledge and guidance needed to design, install, and maintain safe and reliable electrical systems. Remember to always consult the latest edition of the NEC and seek guidance from qualified electrical professionals when working with electrical systems. Safety should always be the top priority.